So where do these critical values of z, or t for that matter, come from? So if you think about the central limit theorem and how we know samples, when random samples fall in a normal shape of normal distribution around the parameter, whether it's a proportion or a mean, what we're going to do is we're going to find that critical value, that cutoff that says, yes, we have a statistically significant result. We're just going to think about this in terms of z-scores. Well, if it's a normal distribution, we know that the mean in the middle is 0, and we're looking for the z-score that cuts off. Let's say I have alpha equals 0.01. That would be a 1% level of significance. And what we're going to do is, if it's a couple of things, if H1 or HA, that alternative hypothesis, is say less than, then I know it's going to be a one-tailed test, and I'm going to put all that error on one end of it. So if that's the case, I know if I have 1% below it, I'm trying to look for that z-score that cuts that off. Well, we know that normal distributions are symmetric. That tells me I'm going to have 1% up on above, and that tells me I'm going to have a 98% in the middle. It's 100 minus those 2%. So now what I've got to do is look up the z-score for that 98%. Well, if you look at that table, that the shortcut, the mini table at the bottom of table 5, we see that at the 1% level of significance, for a one-tailed test, that's going to be the same as, because this is less than, negative 2.33. So that would be the z-score. That would be the cutoff, that z-naught, or the one that we're trying to compare. We do run the test, look at the z-score. If our z-score from the test is out beyond this, down in this range, and then we would reject HO. And that's all this is a z-score. It's associated back to the normal curves, and that's all we need to worry about. If it's a two-tailed test, if this is a two-tailed test, then we got to worry about taking that error, that level of significance, and then cutting it in half, because we got to account for that in both tails. So if I take 0.01 divided by 2, that's 0.005, and that's in both tails. So now what we're going to do is we're going to find the z-score that cuts off the bottom 0.05%. And if I'm looking at that table, we see for a two-tailed test, it's out further. It's negative 2.575 and positive 2.575. Okay, and that makes sense because there's a smaller probability of falling that far away from the mean. Okay, and that's where these levels of significance, or the z-scores and these critical values, come from. Hope that helps.